Hi, my name is Tanesh Analaki Siva, and today I'm going to present you my final year project, which is offline biometric encrypted notepad app with customizable security. So, this app that I've been developing is basically an app where it has a more secure encryption methods included than our normal regular notepad app for some high-end people to use. For example, like businessmen, journalists who wanted to use this app can use it without any worry because nowadays the notepad apps are not as secure as we think. So having our personal or business information secure has never been more important. So a secure notepad app lets you protect your confidential data by using advanced encryption and biometric protection. So we are adding in a lot of elements into this notepad app so that it will be more supportive and more usable for all kinds of people, as we are making it the encryption is also customizable. So it's a choice whether we want it to be as encrypted as a highly encrypted notepad app, or we can use it also as a normal notepad app. So the main problem that led me to do this project is the newest Notepad or note-taking application are often lacking in good security features. For instance, typical utilities like Notepad or WordPad lack encryption and also user authentication. In environments where confidentiality is more significant in business, academic, or journaling environment, personally, this is a serious security issue. Individual must rely on third-party encryption application or encrypt manually. So this is the main issue that made me to have this idea to develop this project. So the main aim to develop this application is to develop a highly secure Notepad application using AES-256 encryption as a main security feature and multi-feature biometric authentication to protect confidential user data in an offline environment. So the objectives of the project is to develop and use a secure note-taking app using AES-256 encryption, biometric authentication, and local encryption of data to eliminate cloud risk. To develop sophisticated security elements such as instant data wipeout, self-destruction, detection of tamper, and end-to-end local backup encryption to prevent unauthorized viewing and data theft. To make secure peer-to-peer offline encrypted notes, transfer via QR codes, and prove the effectiveness of the system to enhance accessibility, privacy, and data security. And the scopes of projects are this assignment is to build a secure notepad application with AES-256 encryption, fingerprint or Face ID login, and password decryption to protect sensitive data. The app will be coded to function offline only. There won't be any cloud or internet capability, and hence no cloud vulnerabilities. The app will support note creation, reading, updating, deleting, safe backup, and peer-to-peer note exchange via QR code. Security features such as auto-lock, tamper detection, emergency lock mode, and a self-destruct feature with customizable setting will be featured. Restriction are minimal use of local storage with no integration of cloud services, and the application will be functional on text-based data alone. The software application will be designed specifically for Android mobile devices and will not support iOS or desktop-based systems under the initiative. So the importance of this project is address the growing need for private, secure, and offline note-taking applications among professionals who handle sensitive data such as business activity and journalists. Through AES-256 encryption, biometric login, and storage on the device, the application ensures the secrecy of information even when the device is stolen or hacked. It also cloud-based attacks and unauthorized online intrusion, making it a trustworthy tool in a risky environment. And the organization of report are follow. We have Chapter 1, Introduction, Chapter 2, Literature Review, Chapter 3, Methodology, Chapter 4, System Implementation Testing, and Chapter 5, Conclusion and Future Work. So next chapter is Literature Review. So the scope of this project lies within the field of electronic note-taking programs. Computer programs utilized to write, store, organize, and manage notes on a digital platform. They have become indispensable in learning, cooperative setting, and daily life, replacing traditional handwritten notes due to greater facility. So these are the importance of the note-taking app that we are going to be developing. So the case study. So this case study is, we have done it based on a survey that we've taken 52 individuals who are in multiple professions, including students, businessmen, journalists, and also some engineers who have answered this survey. So 52 participants were involved in the study, collected through the online survey distributed between 21st to 25th February 2025. The survey contained 15 questions in relation to topic current note-taking habits, data sensitivity, perceived security, and willingness to employ privacy perceiving features. This case study unambiguously presents clear indications of a market gap for secure offline-based note-taking services. The result are in support designing a secure notepad system with features like AES-256 encryption, biometric login, and local encrypted backup, especially for users who work in privacy-sensitive environments such as journalism and executive business. So the current system analysis. So these are the current apps, note-taking apps, some of the note-taking apps, and the analysis of the system. First of all, we have Google Keep, which is a cloud-based lightweight note-taking application developed by Google. So people can jot down informal notes, to-do lists, voice memos, which makes it automatically synced across devices through login to users' Google account. So it's a good cloud-based account. So even though the basic design makes it easy to use, streamlined for frequent use, Google Keep lacks in basic security features such as end-to-end encryption, password, biometric authentication, and the proofs are that have been provided here in the link. So that's the system analysis of Google Keep. Next, we have Evernote. Evernote is an adaptive note-taking software with multimedia attachment capabilities, web clipping, and organized management by using notebook and text. Evernote is widely used by students and business due to its superior search features and cross-platform support. However, Evernote's text encryption is minimal that must be manually carried out by user, but attachment and metadata are not encrypted, and the proof of it is in the link. So next is Microsoft OneNote. Microsoft OneNote is a notebook computer software that allows individuals to create and organize notes in page and section structure. It seamlessly integrates within the Microsoft Office environment and supports rich media inputs such as handwriting, drawings, voice recording. So OneNote has partial offline support through local caches, but stores most of it in the cloud. Next, we're going to see Apple Notes. Apple Note is a iOS-based app. So Apple Note is a note-taking app that comes pre-installed on iOS, Mac OS, and support rich text formatting, checklist attachment, and integration with Apple ecosystem. So it's basically not a Android system. It's an Apple ecosystem. It also offers the ability to log individual notes using Face ID, Touch ID, device passcode, which add an extra layer of device-level security. The risk in Apple Notes is the iCloud. So it is an online platform which raises a third-party data exposure risk. So now we're going to talk about the weakness in the current system. So first of all, it's the iCloud dependency. So most of these note-taking app are iCloud dependent, which uses internet. So the most mainstream application employ cloud storage as a sync and backup measure, but this approach has time and again exposure user to data breaches. So it is exposed to data breaches when it involves internet. So for example, Evernote, a highly popular note-taking app, was hacked in 2013 in a major way, affecting 15 million user accounts along with the email address and encryptor. So this is an incident that has happened in 2013, so which we are trying to prevent in the current system. Okay, so next is the limited encryption scope. So most of these apps, they have biometric encryption, either they have offline method, or either they have auto wipe. So they don't everything have in the same application. So even on some apps with encryption feature, these are typically optional. Some restricted, some not extensive enough for total data security. For instance, Evernote simply allows the user to manually encrypt certain text fields within a note, but not the entire note. So this is the problem with Evernote. So and the proof is there in the link. And Microsoft OneNote supports password protection on a per notebook section level, but also AES 128 encryption as its starting point and doesn't apply to entire notebooks. So the limited encryption scope in some of these apps lead me to develop this this Notepad app. Next is lack in offline functionality. So most of these apps are lacking in the offline functionality. The majority of popular note-taking apps require an active internet connection to function at their best, and therefore less functional in offline or low access environment. So for example, Notion, a very popular productive and note-taking application, has long been criticized for its poor offline support. So this is one of the problems. So the applications are also lacking in emergency security features. So for example, a major failing of most mainstream note-taking applications is the absence of emergency level security. So when a breach happens, I think there isn't an emergency way of dealing it. So for example, while some mobile devices have screen level auto lock, note-taking apps like Google Keep, Evernote, and Microsoft do not have application level automatic locking capabilities. So they don't have an automatic locking capabilities. So these are the lacking stuff in the current apps. So this is the comparison between the current apps, which is Google Keep, Evernote, Apple Note, and Joplin, and also our proposed system is actually at the end, where it is all of the things that these four apps doesn't have. We are adding in our system, so which makes our system more secure and usable for high-end users. So the technology that is being used to develop this system is AES 256 encryption. A secure encryption forms a cornerstone of data protection in modern applications that deal with confidential or personal data. The proposed system is based on AES 256 encryption, a symmetric block cipher algorithm, widely regarded as one of the most secure ones around. With a 256-bit key space, it is virtually impossible to breach via brute force attack, and thus it is adequately suited for defense, government, and corporate use cases. Under the system of note-taking, AES 256 ensure that the notes are all encrypted locally on the phone. This means that even in a hostile individual gains physical access to the phone, the encrypted data is still immutable by attackers in its that not have the proper decryption key by prioritizing local encryption. Next is biometric authentication. So as we see, we are using a fingerprint biometric authentication in our app. The system uses biometric authentication through fingerprint scanning and facial recognition to identify users. Biometric offers a more secure alternative to traditional password as they are user-specific and cannot be easily stolen or replicated. So this is biometric authentication. Next is passphrase-based decryption. So when a biometric access is highly convenient, it's essential to offer an alternative method in case biometric sensor fails or unavailable. There is a passphrase-based decryption and offline encrypted backup. So when the notes are deleted or corrupted, there's actually a backup where it can be in a USB or SD and external media. Also, an internal offline backup can be done in our app. Next, peer-to-peer encrypted note sharing. So, secure exchange of secret notes without relying on internet services is an area of expertise of a proposed system. It offers a peer-to-peer encrypted note exchange mechanism using QR code. If an exchange of a note is required, it is locally encrypted for a temporary time, translated to the scannable QR code, and forwarded to the recipient device without network exchange. The recipient device reads the QR code and decrypts it locally. These methods are traditional means of communication such as email or cloud syncing, both of which are hackable and can be intercepted. Next, autolog and emergency wipe. To future enhance security, especially in context of high risk environment, the system incorporates autolog and emergency wipe. So basically, how does it work is when the password, the biometric doesn't work, and the passphrase is also wrong for a couple of times, and this couple of time can be set by the user. So when it reaches the threshold, basically, these data are automatically wiped from the database. So from the Notepad database, and it can be retrieved from the backup or the external device that you have, for example, USD or any SD card. So this is how the thing works.